Why is it that some parts of the world are warmer than others, even when they are approximately the same distance from the equator? For example, in the Scilly Isles that lie off the coast of Cornwall in southwest England, January temperatures are generally very mild. Frosts are extremely rare, and snow even more so. Average daytime temperatures are about 10 degrees Celsius and nighttime about 5. Yet cross the Atlantic to the city of St. John's in Newfoundland, Canada, and the situation is very different. In January, there's an average 18 days of snow cover, and minimum temperatures at night average -9 degrees. That's a 14-degree difference between those two locations, even though they are at a similar latitude. One important factor is the Gulf Stream, a warm stream of surface water that circulates around the Atlantic Ocean. The North Atlantic Drift is an offshoot that circulates warm water around the Scillies, so the sea surface temperature almost never falls below 11 degrees in winter. In St. John's, at the same time, the sea temperature is 0.5 degrees. The Gulf Stream is partly caused by the circulation of ocean waters, but is mainly driven by winds. The Earth's climate, ocean currents, and global atmospheric circulation, or large-scale winds, are interconnected. At any one time, there are many different weather systems creating localized conditions around the globe. While storms are raging in the North Atlantic in February, in the Southern Hemisphere, Central Australia can be suffering intense heat, and heavy tropical rains might be falling in the Amazon rainforests. The global circulation model explains the Earth's atmospheric circulation. Heating and cooling effects around the globe are driven by wind. The starting point of this model is heat from the sun. Energy from the sun is short-wave light radiation and not actually heat. The heat we feel comes from light absorbed on the Earth's surface, which is converted into long-wave radiation that we feel as heat. So on a warm day, the heat we feel comes from the Earth's surface heating the air around it. Our location on Earth plays a major part in determining the amount of heat we feel. In the Sahara, during the hottest months, air temperatures can rise above 50 degrees Celsius. Over the course of 1 year, the intensity of solar radiation, or insolation, is greatest over the equator because the sun is directly overhead. At the polar caps, the sun hits the Earth's surface at a much lower angle, so the same amount of energy is spread over a much larger area, which means it's cooler. Polar ice sheets also reflect most of the sunlight that does reach the surface. There is an excess of heat at the equator and a deficit at the poles.